Good morning, everyone.
Good morning.
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 Good morning. Is it Leo? That's who's the presenter? Leo.
Yes, this is Leo.
Okay. Leo, yeah, I suppose we're gonna mute, except if you want us to talk.
Yes, I will cover some housekeeping in just a bit. But yes,
Okay,
please do
good.
mute your mic, and then we'll do talking and some questions at the end.
Yeah, because my garden boy is here and he doesn't understand silence.
Okay, perfect. Thank you. Awesome.
Okay.
Cool. Good morning, everyone, and welcome to our 4th live webinar, Starting the Digital Thread, System Requirements and Architecting. Housekeeping before we start, please can everyone just ensure that their microphones are muted, just so that we don't get any disturbances through the webinar, and ensure that your cameras are just switched off for some bandwidth purposes, and we can possibly put them on at the end when we do the questions. If you do have any questions throughout this presentation, please feel free to ask them in the chat. We will get to the questions at the end of the presentation as well. And just to let everybody know that this webinar is going to be recorded. Awesome, so just a little bit about me. My name is Leo Briet, and I am a solutions engineer at Optimum Solutions. Yes, my eyes are indeed open in that photo. It's not just a bad photo. I studied aeronautical engineering at WITS, and I help support our customers in solving their business critical problems, underpinned by the adoption of the MathWorks tools. If you have any additional questions after this webinar, please feel free to contact me on my email address as located in the slide. Don't worry if you can't take it down now, I will show it again at the end of the presentation. If you have LinkedIn, please feel free to connect with me or follow Optimum Solutions on LinkedIn, as we periodically share posts about the MathWorks products and some interesting projects that we do. Awesome, so let's get into the webinar for today. So we're first going to cover what is model-based systems engineering. We're then going to look at the typical system engineering workflow and how Matlab and Simulink can fit into this workflow. We're then just going to cover a short demo on how to model the system architecture of a small UAV, cover some of the key takeaways from this presentation. So I'd first actually like to start off with what some of these key takeaways are going to be. So there are 4 key things that the MathWorks systems engineering solution provides. First, it provides a solution that helps trace and link requirements to the system architecture. It helps provide analytics and simulation for optimizing system architectures. Next, it simplifies complex systems with views which make it easier to communicate with different stakeholders, and provides traceability through project artifacts to understand the impact of a change and quickly respond to changes in a unified environment. So what is model-based systems engineering? According to INCOSE, model-based systems engineering is the formalized application of modeling to support the system requirements, design, analysis, and verification and validation activities, beginning in the conceptual design phase and continuing throughout development and later life cycle phases. So engineers use model-based systems engineering to manage system complexity, improve communication, and produce optimized systems. Successful model-based systems engineering requires the synthesis of stakeholder requirements into architecture models to create intuitive system descriptions. The digital thread starts with model-based systems engineering, which includes aspects such as requirements traceability. For example, you have a UAV that you want to develop, and this UAV is broken down into different components. And those different components or subsystems have requirements that need to be tracked. And this whole process includes being able to track those requirements in one environment, or trying to track those requirements as part of your system architecture. And as part of your system architecture, you need to analyze the behavior of the system and how all the different components interface with one another. You also might be looking at simulation or performance analysis, testing, as well as model-based or simulation-based design. So in this presentation today, we are just going to look at the top part of this systems engineering workflow. But what does a typical but simplified systems engineering workflow look like? Well, you would generally start off with your stakeholder needs. And you'd have a company representative, where this company representative is normally your systems engineer. And that systems engineer is approached by an external client or stakeholder. And as part of this external client or stakeholders' needs, they want to produce or develop a UAV. And this UAV is decomposed into different components and different subsystems. And these different components and subsystems have different requirements that need to be met. So of course, if you're working for a company that can do this work, of course you're going to say you can do this work, because who wouldn't want the business? The systems engineer then takes those external stakeholder needs and breaks them down into their requirements and their use cases. And these requirements and use cases generally come in the form of a Word document, an Excel document. Perhaps they were just sent to you through an email and a list of bullet points. And as the systems engineer, you need to go and break down that document into the functional requirements that each component of the system needs to comply to. As the systems engineer, you're probably also doing the whole system architecture, you're developing the system structure, the behavior of the system. And initially, when you're first starting out, you could possibly have some hand-drawn sketches. Perhaps you're sitting at a restaurant and you drew it on a napkin while you were waiting for your meal. But with later models and increased complexity, you need to be able to track these system architectures in an environment that can do this. And in our case, we use System Composer. And with System Composer, you can also link those previous requirements to your system architecture model. And I'm going to show you how we can do that as well. You also might need to start doing optimization of your design. You might have particular system characteristics that belong to this architecture, or you might have to perform trade-off analysis where you're not really sure which design concept to choose. And we can also do that in this environment that I'm going to show you. You might also need to have some multiple viewpoints as part of this architecture. You could have some key stakeholders, such as maybe management, yourself as a systems engineer, or engineers that are developing the different components of the system need to all have their own specialized views in order to help you manage the complexity of these models. Because let's be honest, as the complexity of these systems increase, you start getting those spaghetti diagrams, and it becomes quite difficult to know where everything works and everything fits together. And we can do that with System Composer by creating specialized views for certain people and certain key stakeholders. This system architecture and the requirements can also be linked up to your design implementation phases, where you might be developing your Simulink models and linking that to model-based design, as well as, and this is where your component developers, such as your engineers, your aeronautical engineers, such as myself, or your software engineers or your mechanical engineers could come into play, and they start developing their own models and linking that up to the architecture and the requirements. And sometimes what we see is that there are some key pains with this whole workflow, that there might be some of the software might be hard to use, might be hard to ramp up on, to learn, and sometimes it's not analyzable or executable. You might have different software to capture your system architecture. You might be performing your simulations in Simulink, in Matlab, and this whole synchronicity might be disjoint. And what we see is that it's quite difficult to respond to any changes. If a requirement changes, how does that track through your digital thread, through your architecture, through your system characteristics, and into your design and implementation phases? We also see that this process is quite iterative and collaborative. So having one environment where you can capture all of these things will be quite beneficial. So how does Matlab and Simulink then work? How it fit into this whole workflow? Matlab, Simulink, and System Composer together create a unified environment for creating descriptive architecture models that seamlessly bridge into detailed implementation models. The connected environment ensures items across the architecture and design worlds stay in sync. Systems engineers can establish a digital thread to navigate between system requirements, architecture models, implementation models, and embedded software. So let's look at a short demonstration of modeling a system architecture of a small UAV. For example, we've got a cool drone that I'm sure a lot of people are familiar with. And this drone might have different components such as your payload, your propulsion, an airframe, a flight support system, and a flight computer. And of course, this is not an exhaustive list because there are a lot more complexity to a simple drone design. What we do is we can have a unified environment where we can capture this all using Matlab and Simulink. So let us go to Matlab. So if you're familiar, this is the Matlab environment, and what I have opened up now is something known as projects. And projects can be done with Matlab and Simulink. It's a collaborative, scalable environment that enables teams to manage their files and data in one place. So as you can see, there are a number of files, and you can also integrate these files with source control so that all your members of your team will be working in one unified environment. Awesome. So what I want to open up for us now is a .slx, a file extension, which implies that this is a Simulink file. And when I open this, you will see that this is very similar to, this is your Simulink environment. And you will see the system architecture as described. We have 6 high-level components. And these components all integrate with one another through connections and ports, very similar to if you've been working with Simulink models. You'll also notice that there are ports that connect externally to the system. And this shows us the data integration between our system and its environment. So the first thing I want to show everybody is how you can specify interfaces for these system architectures. So you want to specify these interfaces because if you have multiple people collaborating on a project, you want to have one ground truth for the type of data that is being transferred between different components in this system architecture. So to do that, we go to our modeling tab and we can select the interface editor, and our interface editor pops up at the bottom, and we can see that there's a drop down of a hierarchy of the interfaces and the data that can be specified in this model. So what you can do is you can select a port, and that port will actually highlight to you which interface has been specified for that port. And we can go and select some of the parameters that are being transferred across that port, and we can see that they have different as well. The next thing I want to show everybody is how you can link requirements to your system architecture. So we can go and we can enter the requirements perspective. And what we'll see again is we have a drop-down. And this drop-down is a tabulated view of all our requirements that have been specified in a Simulink requirements file and linked to our model. And you'll notice that there are some columns with a summary of the description of this requirement. There's an implemented column. This implemented column informs you whether or not you've actually implemented this requirement to specific components of your system architecture. The blue indicates that it has been implemented, and the white indicates that it hasn't been implemented. And there are partial implementations, which shows you in the hierarchy whether or not you've actually implemented all of those requirements. If we select, let's say, for example, we want to see our requirement number 7 with the summary power, we notice that our property inspector pops up on the right-hand side, and we can see the type of requirements it is. We can see the requirement description. We can also then see that this requirement has been linked to a specific component, and it's implemented by our power unit component. And that has been hyperlinked for our use. As these system architectures become more complex, you don't want to be jumping down the hierarchy of all the subsystems. You can just select the hyperlink, and it will take you to the component where that requirement has been implemented. You'll then also notice that there's a little badge on the right-hand side, and that's the badge for our requirements. I can then show that requirement in my architecture view so that if I have someone that's working on the power module, they can always keep up and maintain what that requirement is. Cool. Let me go back up to my high level architecture view. The next thing I want to show everybody is how you can define profiles and stereotypes in System Composer. So to complete specifications and enable analysis later in the design process, stereotypes add custom metadata to architecture model elements. So to do that, you can go to import, and you can import a profile that has been predefined. You go to your files that are saved in your projects, and you'll see that your profiles are defined using a .xml file. We can open that, and you can see that this profile has already been imported into our system. If you do want to make changes to your profiles and stereotypes, you can again go to edit, which will open your profile editor. And once that profile editor has been opened, you can make changes to your model, to your profiles and stereotypes. And these profiles and stereotypes help you to perform your trade-off analyses. So what I want to show you is we want to do an analysis that rolls up and calculates the total mass of our UAV. But we wanted to roll it up from the lowest level component in our architecture to the highest level, because we want to perform a trade-off analysis, as an example, to see what the total mass of the system would be. And to do that, we go to analysis. We can go and create an analysis model, and we get our pop-up for these analyses. And the way that you do these analyses is you write the code to do these analyses in Matlab. And you can actually go and select that Matlab function. You can create an analysis function from scratch. But for our example, I'm going to go back to projects, and we have utilities, which is Matlab scripts. And if I double click that, you can see that this is a normal Matlab function that will calculate and sum up our masses for us in the hierarchy of our components. Let me go back to System Composer, and I want to go and find that Matlab script. So I go to utilities, mass rollup, I say okay, but now I need to select which components of, or which stereotypes of the system architecture I want to do the analysis on, and I want to do it on my whole architecture, and I want to do it in a bottom-up approach. So I want to get the total high-level mass of my system. I say instantiate, and my analysis viewer then pops up with all my masses summed up for all my different subsystems to my high-level system. Awesome. So the next thing I want to show you is how we can create multiple viewpoints using spotlight views and architecture views to help us manage the complexity of these systems. So let's say, for example, you're in a meeting and you want to quickly show a view of your architecture model that maybe just involves the flight support component. So all we do is we right-click on that component and we say create a spotlight from our component. And what that will do is create a spotlight view for us that isolates this component and every other component that it directly integrates with. So we can simplify our viewpoint quickly of specific components, and you can see how these different components interact. But let's say, for example, you have a certain view, you've got the spaghetti diagram, and it's difficult to work through it, and you want to show your structural engineer or a light engineer or an electrical engineer a specific components of this workflow. So you can actually create architecture views that allow you to come back and show these same viewpoints over and over again. So what I've opened up now is our architecture views gallery. I can create a new view, and for example, I want to call this my light command view. Perhaps you want to show this to person that's working on your lighting system of the UAV. And I'm going to create a filtered view first. I can create that. I then need to actually add which components and ports that I want to isolate or filter out of my complex system. So I can add a default view. I say it must select components with a port which have an interface, where I perhaps want to specify a specific name, and this specific name is light command, and I can click apply, and there I have a specialized view just to see the light command functionality of my architecture model. But let's say now perhaps you maybe want to have a specialized view for a structural engineer. So let's call this structural view. You can change the color. Let's say it's orange because that's your structural engineer's favorite color. Maybe you have a relationship like that. And you want to create a free-form view. And a free-form view allows you to drag and drop specific components from the architecture model into a more simplified model. So if this is a structural engineer, they perhaps want to see the fuselage of this airframe, and perhaps they want to see the wings, and there's not really much integration, but that's just what your structural engineer wants to see. So you can create this viewpoint, save it, and then come and refer back to it at a later stage. Great. But now we've shown how this whole system architecture works, but what about integrating this with Simulink? Well, of course, you're asking yourself that. I'm going to give you the answer to it. So I want to go and say, well, I want to create a Simulink model for the main board of my flight computer for this UAV. There's two ways that you can do this. The first way is that if you already have an existing Simulink model for your main board of your flight computer, you can go and link a model to that. Or if you haven't started development on that, you can go and actually create Simulink behavior for that model. You give it a Simulink model name, and you say OK, and that will connect a Simulink model, as you can see that is indicated by the Simulink badge, to that component. And then you, again, because you're in the Simulink environment, you can start creating your system with subsystems, and you can drag and drop your connection ports just like that. Awesome. So what were some of the key takeaways we wanted to take away from this webinar? Well, I showed you that it's easy to trace and link requirements between your system architecture and your requirements, and that there's actually bidirectional traceability. You can optimize your architectures through analysis and simulations by performing trade-off studies, or just calculating maybe the mass of certain components, the length of wires. It can get more complex than that should you wish. And I showed you how you can manage complexity through collaboration with projects and communication with various stakeholders through architecture views and spotlight views. And all of this is integrated into one unified environment where you can respond to changes through the digital thread. Thank you very much for attending today. If you want to get started, you are more than welcome to come and speak to us. And if you would like to, you can watch some of our other webinars that are coming up. And there will be a survey that will be sent out. Once you complete the survey, you'll instantly get the presentation and links to get started creating your digital thread. And if you have any questions after this webinar is completed, please feel free to contact me and we can start a discussion. I want to open up to the floor now if there are any questions. Just to let everybody know, the evaluation form link has been dropped into the Teams chat, and you can just select that chat and evaluate the form or complete the survey for this webinar. Thank you. Are there any questions?
I've got a question, quick. Hi, Leo. Gerald
Hi.
here.
Hi, Gerald.
Apologies if I word this poorly, but I'm just trying to keep my terminology as correct as possible. I see the system requirements specifications look really useful in terms of tracking, your design build. I'm just wondering, I know that there are optimization design components in the toolkit. Is there any functionality to use those optimization the optimization toolbox to guide your design towards those fulfilling those requirements, or is it manual tweaking that you require?
Thanks for the question, Gerald. I believe there is, but my colleague Praneet would be better to answer that for you. So I'll just hand over to Praneet quickly.
Sure thing.
Cool. Hey, Gerald. Cool. So yes, there is. Leo, maybe just mute yours. Just so there's no worries. Cool. So you definitely can do the optimization, and that I believe you might be referring to the optimization toolbox or Simulink design verify or Simulink optimization. So it is possible to link it up. Like Leo emphasized in his last key takeaway that Simulink is a unified environment, so we want to keep it within that environment where you optimize these certain components, whether it be the weight, whether it be certain signals and everything. You definitely can do it through that there. So we showcase basically the starting point, like probably the most essential part of the requirements in architecture, and we need that digital thread to stay throughout the line all the way to code generation. And I understand that there's going to be optimization and all of that, and people are interested in doing that, so that is possible. But you can definitely reach out and we can chat.
Okay, cool. Thank you.
Awesome.
Are there any other questions?
Me again. In terms of the collaboration potential for these projects, I myself have used Git to run the source control. Is there any other functionality besides Git when linking these up, such as TFS for the Microsoft platforms?
Again, I'm going to hand over to Praneet for that one.
Sure thing.
Cool. Hey, Gerald. Sure, there is. I must have heard what other platform you mentioned, but we mostly use Git and SVN for version control. The reason for that is it's well integrated and it's available. We have that available on the Matlab's website and under the documentation tab. But if you could just mention the software that you're using or spoke of.
It's TFS, Team Foundation Server, if I'm not mistaken. I think it's predominantly used in the Microsoft domain. But that being said, I think they are slowly leaning towards Git as well. But it was more out of curiosity than anything.
Yeah.
I was asking.
It most likely can be integrated through that there, like all other third-party software. It's just that Git and SVN are documented and are part of the workflow. But there probably is a plugin or a way around to use other version control software. Thanks.
Okay, fantastic.
Awesome. So if there are no other additional questions, we do have some FAQs that we can go over if you want to find out some more. Awesome. And I'll hand over to Praneet again for these FAQs.
Cool. Thanks, Leo. So probably for those of you that are still in, are wondering how does SysML or other third-party software compared to System Composer. So, System Composer was created to address Simulink users. It was a need and requirement where customers approached MathWorks and said they need something within the environment for Simulink users. It's not to say that it's going to replace the bigger softwares, etc., but it works with Simulink, and you can bring in all the other requirements and architectures into Simulink for that unified workflow. When you design in Simulink, you start off from your design model all the way to cogen. But you can also now bring in this new part where you link the requirements and architecture. Products that are required, System Composer, Simulink requirements, and Simulink test. Simulink test is more for the testing purposes, unit tests and regression tests, etc. What's great about it is that the tests work from the design phase all the way to the code generation phase. Need to redesign test cases. If you already have Matlab and Simulink models, as Leo mentioned, you can link this back to your system architecture model, which is quite easy to do. It's just a right click, 2 or 3 clicks away, and your Simulink model is joined. So Leo's done this graphically, but he wants to do this programmatically. Is that possible? Yes, of course. Matlab is still running in the background. It's still available. It's still there for you to use. So this can be done. And if you are interested, but do not know where to start, you can definitely reach out to us and ask us more questions. Email Leo. His email has been provided, and we will get your survey request. So please do fill that out for us, and we can get back to you if you require additional information. Cool. Thank you so much.
Thank you so much, everyone, for attending today. I hope you have a wonderful Wednesday and a good week. The holidays are almost here.
Thanks, Leo. Bye.
Great. Thanks, guys.
Leo, thanks a lot. We'll contact you. Thanks.